Hello friends, in this session we'll discuss about how to identify merge point or insertion point of given two linked list. So here is an example of given situation. Two linked lists are sharing couple of common nodes. I, J, K nodes are common between these two linked lists. Here the node with value I is called merge point, because this is where two linked lists got merged and using common nodes between them. So now we need to logically identify merge point between these two linked lists. There are various ways to identify merge point between two linked lists. We'll discuss about each and every approach, but finally we'll write code for one of the best approach. The first approach is based on brute force way. In this approach, we will compare node by node from both linked lists. The comparison is not based on value. The comparison is based on node references. We will compare hashes, not the values. Remember this point. We will take two while loops and we'll use them in nested way. This is like inside this while loop, there is another while loop. So the first while loop will be used to read each node from linked list 1. The second while loop will be used to read each node from linked list 2. Inside this while loop, we'll start comparing each node. The moment we found both nodes from linked list 1 and linked list 2 are matching with respect to node references, we will say that's the node we are looking for, which is called merge point. But this is not a best approach. Based on the time complexity, this is one of the worst approach. In our second approach, we will take a set. We will iterate through one of the linked list, let's say linked list 1. We will store all nodes into this set, let's say A, B, C, I, J, K. And then we will take the second linked list, read node by node and verify that given node is part of this set or not. Now first we will take node D. Is it part of this set? No. Then we'll go to the next node E. Is it part of this set? No. We'll go to the next node, which is F. Is it part of the set? No. And we'll continue. At one point of time, the node I, we will find it in the set, so that we'll confirm that node I is the merge point we are looking for. This approach also good, but one of the disadvantages, it requires additional storage. We need to have a set and store all the nodes into the set. In our third approach, let's assume that both linked lists are having same length. For some time, let's assume that these two nodes are not present in the second linked list. So if this is the case, what we can do, we can start comparing these two nodes and these two nodes and these two nodes. That means on both sides, on both linked lists, we can move one node at a time and start comparing node by node. When both linked lists reaches this point, this is a common node between them, which is a merge point we are looking for. Now let's come back to the reality. The length is different for both linked lists. One is greater than another one. Now in such cases, if we can make our node pointer to this point, this approach will make our job easy. So how can we move node pointer till here? For that, what we do, first identify length of the first linked list. So the length of the first linked list is 1, 2, 3, 4, 5, 6. The length of the second linked list is 8. Now what is the difference? 8 minus 6 equal to 2. Take the longest linked list and move node pointers 2 steps. That means initially node pointer will be here. We will move 1 and 2 will make node will point here. Node pointer will be here initially, and then we'll apply same logic. So remember that the initial movement of node pointer to X nodes must happen on longest length linked list. Now let's write code. Create a new class, linked list merge point, create a class called node which is static. It has couple of members. Next is to represent next node reference. Data is to represent node data. A constructor to create node object. Temp is assigned to data variable. We'll create two node references, head 1, head 2, because we are going to have two linked lists. These nodes represents head of each linked list. I'll make them static. Now we'll write a helper method get count. It will be useful while building logic, which returns integer length of each linked list, and we'll pass head node. Since we have to navigate through linked list, we'll take a temporary node reference called current and copy head to this. Initiate count. We will use while loop. The exit condition is the loop will run as long as the current node is not null. So inside this, we'll increment the counter and we will point current reference to its next node reference. So now we'll create, oh, we need to return here, I forgot that. Return count. We'll create a private method which returns node, which is merge point, find merge point. Why private? I'll just explain little later. For now, the input parameters will be diff, which is how many number of nodes we need to move in advance on longest linked list. That count we need to pass here. The second is head reference of longest linked list. The third is head reference of shortest linked list. Since we need to navigate through each linked list, we will take a temporary node references. Node current 1 will be assigned to head 1. Similarly, node current 2 will be assigned to head 2. Now, as a first step, move the pointer on a linked list for int I equal to 0, I less than diff I plus plus. Inside this, current one is the longest one, so we will move the node pointer on current one. So here, as a second step, we will move one step at a time on both linked lists, start comparing each node. So we'll do while loop here. Again, the exit condition is as long as both nodes are not null, we will continue iterating in this while loop. Current 1 not equal to null and current 2 not equal to null. If either of the linked list node is null, that means one of the linked list is reached end. There can be a corner case where the linked list does not have any merge point. Both are independent of each other. In such cases, this exit condition will save us. So now, inside this, we will compare both nodes. Current 1 is equals to current 2. If yes, this is the merge point, return one of them, current 1. If not, we'll move one step on both linked list node. Current 1 equal to current 1 dot next. Similarly, current 2 equal to current 2 dot next. So now we'll write a public method. I forgot to return. So here I am returning null. The reason is if we find a match, we will return the node here itself. If we exit this while loop, that means we didn't find any match. There is no merge point exist. That's the reason we returned null. Now we'll write a public method, and again this returns the merge point. Find merge point. So it does not take any input. What we do here, we'll identify length of each linked list. Count 1 represents first linked list length. Get count, pass head 1, and similarly count 2 represents linked list 2's length. Get count, pass head 2. Now, as discussed, we need to perform advancing nodes on longest linked list only. So if count 1 greater than count 2, that means the first linked list is longest one. So we will call the private method and we'll identify the difference, because count 1 is bigger than count 2, we'll get positive number here, and then first linked list which is longest, second linked list which is shortest, else the second linked list is longest one. So now return find, the difference is going to be count 2 minus count 1, head 2, second linked list is longest one, that's why I'm passing it first, head 1 is the shortest one. So this is the reason we made it private, the first method as private, because we need to identify which linked list is longest one. Based on that, we need to adjust our input values. So now, how to test this code? Let's write a main method. In order to save some time, I have copied main method code from my previous example. Here I have created an object reference for this class. Have created couple of nodes and constructed linked list 1 and assigned a1 node to head 1 pointer. Similarly, I have created couple of nodes to represent linked list 2 and pointed b1 to head node 2. Again, I created couple of nodes in order to create merge point. Now here a4, which is part of linked list 1, is pointing to c1. Similarly, b3, which is part of linked list 2, pointing to same node c1. So c1 is merge point here, and here we are calling find merge point and trying to print data. So when we make a call, we should get data, we should print data which is part of c1. So we should expect 896 as an output. Let's run and see the output. So now we got data which is part of merge node, merge point. Thanks for watching. Please subscribe to the channel.